Hey guys, how's it going? It's Dilmer again and welcome back to my channel. So today I'm going to continue the Unity3d C fundamentals. So I want you to right click on the hierarchy and then create empty. And this empty game object is going to be called video 7. And just like in every other video, let's right click on their scripts, create C# script, and let's call this one video 7. And in the previous videos, I've used Visual Studio 2017 Community Edition. In this video, I'm going to start using Visual Studio Code, and just to kind of show you what are some of the options available for Visual Studio Code. And one of the things that I really like is it's super lightweight. So I'll be showing you more about it as we go through this session. So the first thing that I want to do is I'm going to remove the update method just like we do on every other lesson, and we're just going to keep the start method. So in the previous sessions, I talked to you about creating classes. So we created instances of humans, monsters, players, and a score. And a lot of times we don't need to actually create a new instance if we need to do something in C#. And that's going to be the question today, is like when you would create a static class versus a non-static class. So this is what we're going to be talking about today: static classes and when should we use them. So you might, at the beginning, people might have, suggestions on when to use them, when not to use them. And the way that I try to architect code in C# is I ask myself the question, like, what do I need an instance of? What do I need to create an object of? What do I need to do to create, something that I might need, but I don't need it all the time? So I might need, for instance, to calculate, maybe the motion of an object, and that doesn't really need to be an instance. That can just be a static, a static command that you call, a static method that you call, and then it does something and then it comes back. So let me explain further and actually do something like that. So what I'm going to be doing here is I'm actually going to create a new class. So let's right click on classes, new file. And this class is going to be, we're just going to call it movement. And I'll just say movement.cs because it's a C# file. And I don't want to type everything else. So I'm just going to copy everything that we have here, paste it, and this is just going to be called movement. And I don't really want to inherit from model behavior, so I'm just going to remove that. I also don't need the start method, and I don't need to bring in anything about Unity. So right now this is a class, and which means that it's going to allow us to instantiate a type of movement, but I don't really want to instantiate this. I want this to do basically move an object from one point to another. So I'm just going to call this one static. And when you do a static class, you really don't instantiate a static class, meaning that in other parts of the code, you don't do something like this. So you don't do movement and then movement variable equal new movement. You can't do that in a static class because this is actually static. So meaning that anything that is static, you're going to access like this. So I'm just going to put here, no, this is invalid. And in the next one, we'll do something that is valid. So a static class you can access by just the name of the class and then the period after it, and then any methods that are available within that, or any fields that are available through that, or properties. So what I'm going to do in this session is I'm just going to create a method that you can access as a static method. So one thing that we can do here is we can say, okay, I want this to be public static void, and then I want the movement to have a method that is going to be basically move, and I want to move these by a vector. So I'm just going to say vector 3 and then target position. Perfect. So now that I have this static method inside of the static movement class, how could I access it? So if we go into our formula here, we can do something like movement that move, and then you basically tell it the target position of the vector. So let's say that we wanted to move it, 10, let's say 10 on X, 10 on Y, and then 10 on Z. This is basically how you would call that method. So you notice that I didn't really have to instantiate that. I only created a method that was going to be accessed by the movement static class. So the other thing that I can do here, let's say that I want to do, I wanted to know the size of the game object, or maybe even the name of the game object that I'm passing in. So I could say movement, static string, and then I can also say, I want to know get name. And this might be very simplistic for some of you because you know that a get object has a name property associated with it, but for the demonstration purposes of this lesson, this is gonna help you, starting to realize what a static method and a static class can do. So I can do return object.name. And in here, what I'm going to actually do is I'm going to say, so I'm going to move I'm going to move this object to a target, but I need to know which game object, so I'm just going to pass it in as well, and I'm going to say game object, comma, and then the target. And in this case, also I'm going to say game object and lowercase, because this is the instance, the variable that I'm going to pass in, and we can just say game object.name. And for this one, we're going to say game object that I also need to bring in using Unity engine so that I have access to some of these other Unity type objects. And I can say, in this case, I'm going to say position. I'm going to need the transform, and position equal target. So we're just going to move that game object to that target position, and we can leave those commands above it so that we have them as a reference. So in the instance of calling get name, all I have to do is say movement that get name. But I need to pass in the game object that I'm gonna get the name for. So we can say that we want to get the name for video 6. So we can say game object that find, and we can get basically video 6, and that's gonna return the game object that I find in the hierarchy that has the name of video 6, and we're gonna basically pass that into the get name method and get its name, which we know is video 6, but for simplicity purposes, let's do that so that you know how to call a static method. Perfect. So now let's go into Unity. And one thing that we didn't do, we didn't associate video 7 with the video 7 script. So let's click on it in the hierarchy and then click on add component. And then we're just going to type in video 7 or select it. Perfect. So now let's go back into Visual Studio Code. And one thing that I haven't done, I haven't actually called any of these methods. So what I'm going to do is I'm going to copy our examples from here. I'm going to go into video 7, and in the start method, I'm going to paste them in. I'm going to remove the // and perfect. One other thing that I'm going to do is right now I don't have, so if I call this, I'm not going to get the name. So I need to display it somehow. So I'm just going to create a new variable, and we're going to say video name. And we'll do debug.log video name. Excellent. And the other thing that I'm going to do, I'm going to comment this out because I want to create a cube. Because right now, there's really nothing that I can move. If I move video 7, I won't see anything. So what I'm going to do is I'm going to create a private instance. And we'll just call this one game object. And then this is going to be object to move. And I'm going to serialize it so that I have access through the inspector. And the object that we're going to be moving, it's going to be the one that I associate through the inspector. The other thing that I want to do is I don't want to hardcode this. I'm actually want to control it through the inspector as well. So we can do another vector 6 and then target location. And I'm also going to make it a serializable field. and we can replace our hard-coded value with our target location. Excellent. So let's go back into Unity, and what I'm going to do is I'm going to create a new object. So let's just give it a second until it compiles, and this is just going to be a simple cube. And if we go into, perfect. So this is going to be, I'm going to call this one video 7 object, so that we know that it's basically associated with video 7. And the initial position is fine because we want to have it as 0, 0, 0. So if we go to video 7, we now have a few options in video 7. We have, an object that we want to move. So what I'm going to do is I'm going to associate the object to move with the object that we just created, which is the cube. And then the target location, I'm just going to change it. So we can just move this guy, and we can say, actually the cube, and we can say, we can do something like this. And we can say 1.5, let's just do 1.5, 1.5, and 3. So I'm just going to undo, and we're going to do, the target location is going to be 1.5, 1.5, and 3 on Z. Now let's go into our console. I'm going to clear everything, and I'm going to hit play. And let's give it a second. So we can see that we did get video 6, and we're also getting a lot of things that we don't really want to look at right now. So I'm going to disable video 1 through video 6 and hit play one more time. And we're getting an error on the object reference not in. Okay, let's go back through and make sure that we know what we did incorrectly. So I'm just going to open Visual Studio Code. And this is the kind of thing that I actually like to see, because every time we have errors, it's actually teaching us a lot more about about the tools and framework. So what I did here is I passed in game object define video 6, which I actually disable. So that's why we're getting the error. So I'm actually going to change this to video 7, since we know that one is going to be active. And even better, we can do a checking here just to make sure that we don't have this error in future lessons. I'm going to say game object define, it's going to be the variable name, equal game object define the video 7, and we're only going to do this if we find the object. So I'm just going to say as long as this is not null, I'm going to do this. And we can say make sure we find the video before we call movement.getName. Perfect. Just a few comments in there so that we know what we're doing. Let's go back into Unity, and I'm gonna clear the log, and the script is compiling. Excellent. So now let's hit play one more time and see what happens. Excellent. So now we see video 7, and the reason why we're seeing video 7 is because we're actually calling into getName. We're trying to find video 7, and we're getting the game object name back. So let's look at something else. So the other thing that I want to look at is we started as 0, 0, 0, and you can see that this is actually offset by, the cube is offset by 1.5, 1.5, and 3. The reason for that is because we use the static method movement, that move, to move the game object from 0, 0, 0 to 1.5, 1.5, and 3. So that static method is working fine. And the other thing that we did on the static method is we did the movement that getName, which gives us video 7. So what would happen if I name this something else? Let's say that we name this video 7 blah blah, and we go back in here and actually look for that blah blah, and go back into Unity, hit play, and we're gonna see, we should be seeing the perfect. It looks like we didn't really see a console entry for that. And let's make sure that I did do it right. And Let's do this one more time. So video 7, just call this one video 7 more info. And I'm gonna copy that exactly here. Oh, I see what's happening. We also need to tell it this is the game object that we want to find. So instead of trying to find it one more time here, we can just pass in that variable. Perfect. Let's go back into Unity and let it compile. And let's just hit play. And we can see video 7 underscore more underscore info. So we did find the object and we're printing its name. And the other thing that we did, we also set the video 7 object. So if you notice, just to recap, we didn't really have to create an instance of movement. All we did is we made it a static, and then we call the method, a static method called move, and we pass in the game object in the target location. We also did add another method called getName, which we didn't really need to instantiate movement, just like I showed you, but we just call the static method getName just by using the static in that notation. So the other thing that I want to show you is what would happen if I make, if I make these ones non-static and go back into video 7, and let's just try movement and hit that, or even better, let's go back into Unity and then hit play. And if you notice, we don't really have access to movement or getName, because it says I cannot declare instance members in a static class. So the problem with this is the static is telling the compiler that anything that we basically define inside of its implementation needs to be static. So this is only available if I create an instance of movement, but because I'm telling the system that this is going to be a static class, then I won't have access to it. So I will need to do something like this: a static, and then a static. Now if I go back, it's going to work just like it did before, because those two methods are now static. And let's give it a second, and that everything is working. So why do I need to make this class static? So in reality, I really don't need to make the class static. The methods I could make static, but I could make it static if I wanted everything that is implemented inside of it to be static. So I could also make this non-static, and that's still gonna work. So if I go back through and I hit play, and we should also see the object getting moved, which it did, and also I'm getting the name of the object. So the cool thing with this is actually going to allow me to create, a few static methods, and I could also create an instance of movement. So why would I do that? Well, maybe I need something in here to be, instantiated. Maybe I need another method that actually needs an instance. I might need to store, say that I wanted to store, for instance, the location of the movement, the target location, for instance, or something else about it. So in this case, I could say, okay, I want to store maybe the X coordinate. I might need to store the Y coordinate. And the other thing that I can do is I can actually, create a constructor that takes in X value and a Y value. And I can say that the X equal X, that the Y equal Y. And this is completely fine. And what I'm going to do here is I can do debug.log X equals, and we can say X equal X. And I'm also want to print out the value of Y, which is going to be the Y and Y. So the compiler is not going to complain about this, because I actually told the compiler that this class movement could actually be created as an instance. So if I give it a static class, the compiler is going to complain because this is actually not valid in a static class. But if I do it like this, it should work. And now not only I have static methods that I can access through the movement class, but I also have a constructor that is going to allow me to create a movement object. So let's see this working. Let's go back into video 7. And what I'm going to be doing here is, let's actually do it at the end. So what I'm going to be doing is I can say movement object equal new movement. And I can pass it in the constructor. What I'm going to be doing is the target location.y, comma, target location.x and target location.y. And the other thing that I'm going to do is, actually that's perfect for now. Let's go back into Unity. And let's hit play and see what we get. So we're getting an error. Oh, I see why. Because the vector 3, it's actually a float. So x, y, and z are float values. So instead of doing, just change the type in the movement class. And these are actually going to be floats. And this is going to be a float. And this is going to be a float. Perfect. And let's hit play. And looks like we got our object was moved. We did get the information about the name of the game object. And we're also getting information that came from the instance created of movement. So that basically shows you the power of using static classes and also using static methods with instance of classes. So if you guys have any questions about these, let me know. I'm going to be checking this in into GitHub, and you're more than welcome to basically pull the code and look at the examples that I created. Thank you guys.